Lesson 41, functions. First of all, let's go through what a function is. A function is just a mathematical rule that identifies a relationship between two sets of numbers. And so I like to think about it as a machine. So down below here, you can see I have a machine here. You put something into the machine. That would be your input. And then the machine is programmed to do something to the input. And we would call that function a rule. So you put like a number or you put a variable in to the machine. It does a rule or uses the rule on the input, and then out comes a new product, the output. Okay, so it's important that you know that each input can have only one output. So if you put a number into an equation, you can only get one answer out. And so we have what we call a linear function. All points form a straight line. So when we put a number into an equation, you get a output. We can plot those points with our inputs and our outputs on a coordinate plane, and then connect all of our points, and it forms a straight line. And then we're going to look at today proportional. Proportional just means the ratio of the output to the input is constant. So there's a consistent, or you could say there's a slope when we're talking about slope-intercept form, or you can say that the rule is going to be your ratio. So let's take a look at an example here. The perimeter of an equilateral triangle, remember equilateral triangle just means all the sides are the same length, is 3 times the length of one of its sides. Write an equation that expresses this relationship. Use P for perimeter and S for side length. So if we were to find the perimeter, P for perimeter equals, and we would have to find perimeter of anything, we're just adding up all the sides. And since an equilateral triangle has the same side length, we have 3, and then S is for the side length. So 3 times the S, or if it would have been S plus S plus S. But the simplified form would be 3 times S. Now it says choose 4 different side lengths. Make a table to show the relationship between the side lengths and the perimeter. And then graph the points with side length being the x coordinate and the perimeter being the y coordinate. So over here, you can see I have S, which is your x, and P here being your y. We need some side lengths. So let's just say that one equilateral triangle side length is 1. If each side is 1, 1 times 3 gives me 3. I'm just putting my side length into my equation for S. Now if the side length is 2, each side is 2, 2 times 3 would give us 6. And then let's say our side length was 3, we would do 3 times 3, which would give us 9. And if the side lengths are 4, 4 times 3 would give us 12. So there's our table. Now we just need to plot our points on our graph. So we have 1, 3. So I go to 1 on the x-axis up to 3. 2 on my x-axis, 6 up. 3 on my x-axis, I go 9 up. And then 4 all the way up to 12. And then I can draw my line to connect them all. And there I have a linear function. And the rule is just, or the function is just telling me to multiply whatever I put in there times 3. And I can check that because 1 times 3 gives me 3, 2 times 3 gives me 6, 3 times 3 gives me 9, and 4 times 3 gives me 12. So we would say the function or the rule is times 3. Next example, Xavier and Yolanda are playing a game. When Xavier says a number, Yolanda performs an operation with Xavier's number and says the result. The table shows 4 numbers Xavier said and Yolanda's replies. Describe the rule Yolanda uses and write the rule as an equation. Then graph the XY pair from the table. If we look at their table, you go from 2 to 4, 3 to 5, 4 to 6, 5 to 7. Well, to get from 2 to 4, it's either 2 times 2 or 2 plus 2. I'm going to try 2 plus 2. 2 plus 2 is 4. Now, for this to be a function rule, it has to work for all 4 pairs. Does 3 plus 2 give us 5? Yes. 3 times 2 would not give us 5, but 2 times 2 would give us 4. So that's how I know that it's not times 2. It has to be plus 2, because 4 plus 2 gives me 6, and 5 plus 2 gives me 7. So the rule that Yolanda uses is you add 2. So you add 2 to the inputs. And then we need to write a rule. So your y is equal to your x plus 2. Because whatever I'm putting into the function, I'm just adding 2 to it. And you can see the table is there, done for us. Now we can graph it. So let's plot our points down. So we got 2 and 4. So 2 all the way up to 4. We got 3 to 5. 4 to 6. And we got 5 to 7. And then I can draw my line, connect them. There's my line. And there you have your linear function there. Next problem. The area of a square is a function of its side length. The graph of an area function is different from the graph of a perimeter function. For the function a equals s squared, describe the rule in words that make a table with at least 4 pairs of numbers, and then graph. So what are we doing with our function? We are squaring the input, or you can square the side length. So now let's come up with our points. Now, since we are doing area, we can only really use positive numbers. So let's say the side length. Side length is 1. So if I square the 1, I get 1. The side length is 2. I square the 2 and I get 4. I have the 3. Side length of 3, I square that and I get 9. And I have 4, square that and I get 16. Now if I come to my graph over here, I don't have 16 lines going up, so I'm going to count by 2's. So this would be 2, 4, 6, 8, 10, 12, 14, 16 would be here. And then we'll just count by ones, or yeah, ones here. So 1, 2, 3, 4, 5, 6, 7. This would be -1, -2, -3, -4, -5, -6, -7. So now if I plot my points here, I got 1, 1. I got 2, 4. I got 3, 9. Got 4, 16. if I were to draw my line here, just going up like that. But with this one, since I'm squaring it, for this problem, because we're looking at just area, you can only have positive numbers. But look what happens if I put a 0 in. If I put a 0 in for x, so I'm just going to continue my table down here. This is my x and this is my y. If I put a 0 in, I square the 0, I get 0. I'm going to put a point at 0, 0. If I have a -1 in for x, -1 times -1 is 1. So this would be -1, +1. If I put a -2 in there, -2 squared is +4. So 2 up to 4 would be here. If I put a -3 in here, -3 squared is 9. So I go to 3 all the way up to 9. And then if I put a -4 in, -4 times -4 is a +16. So if I go to 4 all the way up to 16, that would be right here. And now if I continue my graph to connect them all, it forms a parabola or a U-shaped graph. So when you have a square term like that, we would call that a quadratic. And any quadratic, when you graph it, forms a parabola shape or a U-shaped graph. But for this particular problem, we would only use the positive numbers because they're dealing with area of a square and you can't have negative side lengths. I just wanted to show you what the graph would look like if you have a quadratic. Next one, the relationship between feet and inches is a function. Write an equation that shows how to find the number of inches and is your output. If you know the number of feet, I, for input, then make a function table that shows the number of inches in 1, 2, 3, and 4 feet. Graph is optional. Right? So we are still going to graph it, but we want to answer two questions. Is the relationship linear? And then is the relationship proportional? So we're going to come over to our table here. I'm just going to change this right here, change these. We're going to use the variables. The n our I is our input, so input goes on the left, and is our output on the right. So if we put in 1 foot, how many inches would that be? 1 foot is 12 inches. So let me label this one. This one is feet, this one is inches. 2 feet would be 24 inches. 3 feet would be 36 inches. 4 feet would be 48 inches. So now if we were to graph this, and we can graph this just for practice, we can count by, let's count by sixes. So we could call this 6, 12, 18, 24, 30, 36, 42, 48 would be up here. And then these are just count by 1, 2, 3, 4. And let's just plot them. So we got 1 and 12. Be here, 2 and 24. Be here, 3 and 36. Be here, 4 and 48 would be here. I can draw my quick line here. So now, is the relationship linear? Do we have a straight line? Yes, we have a straight line because our graph proved it. Is the relationship proportional? In order to determine if it's proportional, we could just take two of the points, or actually just take our inches and put it over our feet. So if I do that, I have 12 over 1, which gives me 12. I have 24 over 2, which gives me 12. I have 36 over 3, gives me 12. And I have 48 over 4, which gives me 12. To find if it's proportional, you take your output divided by your input, and that's what I did here. And if all the numbers are the same, they are proportional. Next problem. Yolanda played a new number game with Xavier. She used this equation to generate her response to each number. Xavier said y equals x minus 2. Describe the rule in words. We are subtracting 2 from the input, which is our x. Now we need to make a function table. The function table is here. And so like this would be our x, this is our y. Let's put our numbers in there. So if I put a 0 in, subtract 2, and again negative 2. Put a 1 in, minus 2 is a negative 1. 2 in there, minus 2 is 0. 3 minus 2 is 1. And I'm just going to graph this very quickly. I got 0, negative 2. Got 1, negative 1. Got 2 is 0. And I got 3, 1. Draw a line here. Is the relationship linear? Yes, it forms a straight line. Is it proportional? If I take a negative 2 divided by 0, I can't do that. Can't divide by 0, so that's undefined. Negative 1 divided by 1 gives us negative 1. 0 divided by 2 gives us 0. And 1 divided by 3 gives us 1/3. They are not the same, so no, it's not proportional. Next one, graph this function, y equals half x minus 2. Says you may use a table or use the y-intercept and slope to find the points. We're going to do both of them here. Okay, so there's your x and there's your y. If I don't want to use fractions in here, for my numbers, I'm going to use certain numbers so I don't have fractions. So if I put a 2 in there, half of 2 is 1. 1 minus 2 is negative 1. I'm going to put a 4 in. Half of 4 is 2. 2 minus 2 is 0. I'm going to put a 6 in there. Half of 6 is 3. 3 minus 2 is 1. I'm going to put an 8 in. Half of 8 is 4. 4 minus 2 is 2. Now let's plot our points. These are all going to be counted by ones. So I have 2, negative 1 here, 4, 0 here, 6, 1 here, and 8, 2. 8, 2 would be up here. Now I can draw my line here. So that's using the table. Now I'm going to use a different color to show you how you can do it without a table. This number here is always your y-intercept. That's your y-intercept. That's where it crosses the y-axis. So if I go to my graph here, my y-axis, I go to negative 2, would be right here. And then I use my slope, 1/2. That means rise over run. So I go up 1 over 2. So up 1 over 2, 1, 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. And then if I draw my line, you can see that it's the same as what I did with my table. So that's just another way of graphing a linear function. Next one, state why the relationship between the numbers in this table is not a function. Okay, so if we look at our numbers, we got 0, 0, 1, 1, negative 1, negative 1, 2, 2. This is not a linear function because if you notice, I have 1 both times is my input, but I have 2 different outputs. That can't happen. So the relationship between this is not a function. So not a function. Because the input 1 has 2 different outputs. So just remember, one input can have only exactly one output. Otherwise, it's not a function. So that is our lesson today on functions.